Have you ever wondered how an airplane engine could handle more than just the sky? Well, we're diving into the world of jet engine testing, from facing off against water cannons to chicken guns and surviving icy blasts. Get ready as we take a ride through the complex world of engine testing. Before we dive into the distinct ways of testing something as intricate as a jet engine, do you know why it's significant to even test them? The first and foremost reason is your safety. When you're hurtling through the atmosphere at cruising altitude, there's no room for error. Testing is the linchpin of aviation safety, ensuring that these engines can withstand the relentless challenges they'll face during their airborne journeys. Now, before we get deeper into the intriguing jet engine world, make sure to like, subscribe, and leave a comment below to let us know you have joined us on this adventure. To begin with, let's take a trip back in time to 1940 with the de Havilland Mosquito, a plane made of wood. Engineers hurried testing, and some aircraft broke apart mid-flight, showing us that rushing through tests has significant ramifications. Not only this, but in the 1950s, the world's first commercial jet airliner, being the DH-106 Comet, had 3 highly publicized accidents within its first year of service. These and many other early accidents have very carefully taught the aviation industry that cutting corners on testing can lead to serious consequences. We will now go through the jet engine testing process step by step from one test to the next. First off, let's talk about water, not just a gentle drizzle, but a full-blown storm. During water ingestion tests, engines are subjected to rain equivalent to 20 inches per hour, replicating extreme weather conditions. These tests help engineers assess the engine's capability to handle heavy rain during all stages of flight, but particularly takeoff and landing. Cold weather can also be a real difficulty for jet engines. To tackle this, they fire huge balls of ice into the engine to see how it handles the cold. Beyond this, they take these engines to seriously chilly spots like Canada's super cold Arctic. For a whole week, these engines face temperatures as low as -28 degrees Celsius. That's -18 degrees Fahrenheit. They test them on the ground and up in the air to ensure that the engine's performance is not compromised in icy conditions, a critical consideration for flights in colder climates. Now, bird testing may sound like an odd job, but in the world of aviation, it's a crucial task. Imagine a scenario where a plane cruising through the sky unexpectedly collides with a flock of birds. The consequences could be catastrophic, with potential damage to many components of the aircraft's engines, possibly leading to an emergency landing or worse. Statistics show that each year there are over 13,000 reported bird strikes in the US alone, costing the local aviation industry over $1.2 billion annually. This staggering figure emphasizes the financial impact of bird strikes and underscores the significance of rigorous testing to mitigate such risks. Engineers have come up with innovative ways to ensure that airplanes can safely navigate through the skies, even in the presence of our feathered friends. One of the peculiar methods involves what's known as a chicken gun, a tool designed to simulate bird strikes. Before an airplane takes off for the first time, manufacturers conduct tests on the engines to guarantee their resilience against bird strikes. Using the chicken gun, they literally shoot dead birds into the running engine at high speeds. This peculiar test mimics the real-life scenario of a bird colliding with an aircraft engine during flight. But the testing doesn't stop there. The windshield, a crucial part of the aircraft, is also subjected to bird bombardment. Birds are fired at it using the same chicken gun to ensure that it can withstand the impact and continue to protect the pilots and passengers inside. Now, for blade-off testing. Blade-off testing is like a safety check for an airplane's engine. The tests make sure each blade stays firmly inside the engine, avoiding any chance of it flying off. If a blade does come loose, it could cause serious damage, way worse than a bird hitting the plane. It could hit other parts of the engine or even pierce through the plane, which is really dangerous for everyone on board. During the tests, they make sure the blades are securely fixed. They even use a tiny explosive at the bottom of one blade while the engine runs to see if it stays in place. If a blade pops out during these tests, they go back to figure out a better way to keep the blade safe inside the engine. Flight crew do their best to avoid storms, but there is always a slight chance of getting hit by lightning. Statistically, each and every commercial aircraft gets hit by lightning at least once a year. Some keep flying without a hitch, but others have problems with their engines because they aren't fully protected. Lightning can mess up an engine, causing significant damage that's sometimes impossible to fix. In the past, it even led to emergency landings or crashes. To stop this, airplane makers created tough shields to handle lightning strikes. They've been searching for better materials too. Carbon fiber seems promising because it's stronger and lighter than aluminum. Using it makes planes 25% more fuel efficient. But even with these new materials, planes still need a layer of metal mesh or foil to stay safe from lightning strikes. Engines are therefore tested rigorously to make sure they can handle high voltage without catastrophic consequences. Fire tests are an integral part of jet engine safety evaluations. During fire tests, engines are subjected to controlled flames to assess the response of various materials and components. This includes the engine's ability to contain and mitigate a fire within its structure, preventing further damage and ensuring the safety of passengers and crew. Last but not least, moving from ground tests to in-flight testing means taking the engines up into the sky to see how well they perform. Before this stage, the engines have passed all their previous checks and ground assessments, showing they're ready for the big test in the air. For these special tests in the sky, they use modified airplanes made just for testing engines. These planes, often converted old Boeing 747s, might look strange because of where their engines sit, but they're crucial for determining if the engines work well enough to keep a plane flying smoothly. GE Aviation's Airborne testbed, the Boeing 747-400, has flown over 10,000 flights, accumulating more than 24,000 flight hours, contributing significantly to the development and improvement of their engines. Only when they pass all these tests do they get the okay from the Federal Aviation Administration to go into production. In-flight testing isn't just a routine thing, it's the engine's big chance to show what it's made of. The sky becomes its stage, and engineers and regulators keep a close eye on how it performs. Doing well in these tests means the engine isn't just an idea anymore. It's proven it can work for real and keep planes safe. As we unravel the complexities of jet engine testing, it's essential to recognize the global impact of these endeavors. The aviation industry is a cornerstone of the global economy, connecting people, cultures, and businesses across continents. According to the International Air Transport Association, IATA, the aviation industry contributes over $2.7 trillion to the global economy, supporting over 65 million jobs worldwide. Jet engine testing plays a pivotal role in maintaining the safety and reliability of this vast network of interconnected flights. And so, we conclude our extensive journey into the intricate world of commercial aircraft jet engine testing. Beyond the sleek exteriors of these flying behemoths lie the meticulous craftsmanship, precision, and innovation that propel them through the vast skies. If you've marveled at the unseen complexities of jet engine testing, share your thoughts below. What aspect of aviation would you like us to explore in the future? Until then, blue skies and safe travels. Remember to like and subscribe for more enlightening adventures into the world of aviation technology. Stay tuned for more videos.